Hello friends, how are you? I hope all of you are doing well and then maintaining your studies. I hope that you're staying home, staying safe, as well as doing your studies also well enough, right? So, okay, today in this class, what I'm going to do, what we are going to be doing is we'll be solving more problems on limits. As we all know that the questions on the NCRT textbook are actually not quite enough, okay, for us to practice. So what I've done is I've just picked up some random questions from different textbooks and then I've decided to solve so that it may be of some help to you to get to know how to mathematically solve the problems on limits more properly. So it will give you more varieties, it will give you more variation. So maybe I'll just solve around about 7 8 questions, just some random questions from different textbooks which I believe that might give you good enough practice. So bring out your pen, paper, and then alright, let's just begin with the exercise. So the first question that I've written here is this. So as I have been telling you in the first one or two previous videos that we can continue with the limiting value of the limiting value as x tends to 3. It's not x equal to 3, okay? We're just assuming, as I discussed in the earlier videos, right? So if we just assume x to be 3, then what shall we have here? 3 square, 9 minus 4 3s are 12 plus 3. And here 3 square, 9 minus 2 3s are 6 minus 3. So what we have here is 12, 9, 0. So we have here what? 0 upon 0. So as we know that this is meaningless or indeterminate in mathematics. So that means there has to be some solution or we have to simplify this further. So we will continue with the value of this limit x tends to 3 till we are confident that we are not getting 0 by 0, more importantly. So sorry, okay, let's just factorize this. Maybe we can factorize this, that is using splitting the middle term. So class 11, I believe you also know how to split the middle term. So let's begin. X square minus 3 ones are 3. So 3 ones are 3 minus 3 minus 1, that's 4 plus 3. Similarly here, x square minus, so 3 ones are 3. So I can have 3 plus 1x, that's minus 3 plus 1, that will be 2 minus 3. So limiting value as x tends to 3, x common, x minus 3 minus 1, x minus 3, all divided by x minus 3 plus 1, x minus 3. Please do not forget the concepts of mathematics, okay? It's very, very important. Okay, so I'm going to wrap this off. This one also I'll continue here. So that's going to be limiting value as x tends to 3, x minus 3, x minus 1 upon x minus 3, x plus 1. So, okay, it's better to use brackets, x minus 3, x minus 3. So what do we have here? That is limiting value of x tends to 3. We have x minus 1 by x plus 1. See, one thing is that you just cannot take the value of the limit out of the x, or the variable concerned, just out of the limit, okay? That is not possible. You can only do that when that particular value is not going to be affected at all by the change in x. So we will come across those kind of problems, alright? So, see, now here what we do is if we use the value of 3, we know that we are not going to get 0 by 0. So that means now we can use the value of 3, that's the assumed value where x tends towards 3. So in that case, mathematically speaking, this limit now goes, because now we're using the limit. So the limit can be removed because we have already used that limit. So it's like using it once, So one life, something like that. So 2 by 4, so that's going to be 1 by 2. That means the value of that function, limiting value of that function as x tends to 3 will approach 1 by 2. That is the solution. Okay. So that's how we will do. So this was this was an easy problem. Let's solve another one. That is maybe another question that we can solve is, okay, this is going to be an interesting question. That will be limiting value as x tends to 0, root over of a plus x minus root over of a upon x root over of a into a plus x. Okay, this is the question. So now let's see, if we substitute the value of, not substitute, if we use the value of x equal to 0 directly, what do I have? A plus 0, that's a minus root a upon, this is already 0 because x into 0. So what we have here again, 0 by 0. So that means here also we will have to simplify. So now let's see how we can simplify. You remember rationalization? Rationalization of numerator and denominator. So maybe we will just try rationalizing the numerator here. So that is, it depends, okay, it depends on our way we solve simplification. There is no hard and first rule, only one method and all. No, it depends, as long as it is mathematically correct. You have to be very careful with that. So I'll rationalize the numerator. So what do we do with rationalization? Plus the opposite sign, no, just the additive inverse. Multiplying and dividing by the opposite sign, plus. I'm rationalizing the numerator. Most of the times we do it with the denominator, but no, it can be done with the numerator also. So I've divided and multiplied by this value. Okay, maybe I can just keep it separate, something like this. So then let's, what am I trying to do here? I'm trying to simplify so that I don't get 0 by 0, because here I was getting 0 by 0 if I use the value of x. So now this is c. Do you remember this formula? A plus b into a minus b. Difference of squares, a square minus b square. Very, very important, all this basic stuff, no? A square minus b square. So now you see a plus b, same values, a minus b. So that can be a square minus b square. And this value, let it be as it is. We will not simplify this. Not very much interested in simplifying that. Neither do we multiply. A plus x plus root of a. Alright, so I'll just write one more line here. Limit as x tends to 0. I think visible. So now this is square root, that's only a plus x minus a. So x upon root of a plus x, root over of a plus x plus root over of a. Alright, okay, let's see what happens. So it is done, right? A cancels. Okay, so just to save time, I'll be just writing down the next step by just modifying this a little bit. Alright, just to save some time, and on top of that, I'm quite lazy also. So next step, okay, next step, what happened? This is already equated, so we have x upon this. Now let's see if we can put x equal to 0. No. And one more thing that we can do here is, see, these are all products, so x 1 times each, so that is also done. So I think the problem is already solved. X tends to 0. 1 upon root of a plus x, bracket root of a plus x plus root over of a. So now we can use the value of x tends to 0, so limit can be removed. So what do we have here? Once the limit can be removed, a, please use maximum steps, especially when you're learning for the 0, so for the first time. Now after that, slowly you can proceed to reduce the steps, but don't, right from the beginning, don't try to go for shortcuts. Have some patience. Check out the steps, learn the topic properly, and then only you proceed with writing down the steps, shortcuts I mean. Because most students, what I see is they are like, this is root a into a, square root of a into a, that's going to be a. Most of the students that I see is into root a. They are very much interested in shortcuts and all. Don't worry, man, you are going to learn definitely all those shortcuts, tips and tricks in time. After you perfect the topic properly, after you learn the topic properly, definitely you can use the shortcuts. But now what I basically believe in is when you are learning something new, always try to just elaborate on things. Use to write down the steps and step by step, and that's how we learn. Okay. All right. Another question. Limiting value as x tends to 0, sine of 2x plus 3x upon 2x plus 3x. Okay, this is also going to be a good question. So now what I will do is, here also if I put x equal to 0, I'll have 0 by 0, so that is also not possible, so I'll simplify. So what I'll do is I'll divide each term by x. So that's almost same, 2x by x, that is just similar to multiplying and dividing by x. No, that's all right. So what happens is x done, x done. So sine 2x by x plus 3 upon 2 plus sine 3x by x. Alright. So that's the step that I get. Alright. Is that clear? So the next step, what shall we do? Is let us use the algebra of limits. That is, we will distribute the limits. Let's write down the steps as I was just telling you now. Steps are very important. Once you know the steps properly, maybe after that, okay, you can skip some of the steps, but at least see how it is done. Why is it done? No, because without knowing exactly how is it done, why is it done, we just write something, we just copy from the textbook, we just write something, then how are we really supposed to know how and why it happened, isn't it? So we really need to know, right? As science students, we really need to find out the reason to why certain things happen. So now here what happens is, see, we know there is one formula, that is limiting value of sine theta upon theta as theta tends to 0 is how much? 1. So these angles should be same, theta, theta. So this is not same, so maybe I'll just multiply by 2 and divide by 2. Here I'll multiply by 3 and divide by 3. So definitely we all know as x tends to 0, 2x tends to 0, 3x also tends to 0. So our angle here is 2x, so 2x tends to 0, 3x tends to 0. We can do that, no problem with that. So in that case, this is going to be, okay, this value, limiting value. So for that case, maybe, okay, I'll just write one more step again. No problem, since we just want to know how is it exactly happening. 2x plus. Now, in that just one of the previous problem was telling you, see, limiting value of 3 as x tends to 0 will remain as 3, because what happens here is the value of x, literally what happens, no matter what happens, is not going to affect the value of 3, because the value of 3 will remain as 3 only. Because if I tell you what is the value of 3 if x is 5, now 3 is a completely independent term with respect to x. There is no x here, so x is not going to have any effect on 3, isn't it? We are going to talk about this related to this in derivatives also. So 3 is not going to be affected at all by the value of x, so that's why 3 will remain as 3. So that's why when you talk of only constants, it doesn't play any part, that's why 3 remains 3. Similarly 2, constant, no problem, no changes because of x. So 3 common, sine of 3x tends to 0, limit sine of 3x by 3x. So now this value we know that it is 1 plus 3 divided by 2 into 3, 2 plus 3 into 1. So that's going to be 2 plus 3 by 2 plus 3. So that's going to be 5 upon 5. So that is 1. Alright, so that's how we are going to be supposed to be solving systematically, stepwise. Okay? Okay, another question. limiting value of x tends to 1 of 2x minus 3 root over of x minus 1 upon 2x square plus x minus 3. So here also the same thing again, we will get 0 by 0 if we put x equal to 1. So what we will do is we will try and simplify. These are all practice questions, so this is going to be like good enough practice for you, because mathematics, the secret behind being good in mathematics is practice. Only practice, no shortcuts to mathematics, okay? It's only about practice, 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 practice. Don't expect just to learn mathematics overnight, okay? It's all about practice. Nobody can do that. There's no magic in mathematics. It's all about practice. Maybe I think you can see, so minus 1 into x plus 3. So I think that's fine. Okay. So that's a limiting value as x tends to 1. 2x minus 3 root of x minus 1 2x plus 3 x minus 1. So still we see that our problem is still not solved yet. Our problem is still not solved yet. So anyway, what we will now do is then, because here you put 1, 2 minus 3, but here 1 minus 1, 0, 1 minus 1, 0. We're still having 0 by 0. That means there's still some, don't worry, this was also not waste, okay? It is going to really come into handy. But what that means, we still have to do some more simplification. That is, now I see, okay, maybe I can rationalize this denominator x plus 1, x plus 1. So if I had identified the problem right from the beginning along with this factorization, I also would have continued with this rationalization from this step itself. You can try that by that method also. It's all actually same, just saving 1 or 2 steps, that's all. So that's going to be limiting value x tends to 1, 2x minus 3. So now again, a plus b, a minus b. So the formula will be a square minus b square upon 2x plus 3 x minus 1 root of x plus 1. Limit x tends to 1. Actually, I have decided to do all this like some extra problems just for the sake of those students who may not be having any access to any other books except the NCERT books. I know that there will be many students who will be having different varieties of books and all, but we all know that this channel was created just to help students, actually all of you, and especially those students who don't have any access to different books or online learning, online classes, or facing shortage due to of mobiles at home. So we all know that this channel was purely created just for those students. So this is just what I want to share through this channel, is that don't be disappointed if you have nowhere to learn. I am there to help you out. I just need your support. That's all I want, because as long as all of you do well, that's always, what do we call it? That's always, a good thing. It's always a proud moment for us when students do well. Yeah, I think that's all right, especially just leaving aside that topic like 2x minus 3. 2x plus 3 root 1. So now I know that I'm not going to be getting 0 by 0, so I remove the limit, use the value of x equal to 1. So that's how I get minus 1 by 10. So now sometimes what happens is, we as teachers, in the process of trying to expect and trying to mold you in the right path, sometimes we might seem to be harsh to you. We might seem to be harsh, we might be sometimes harsh and rude to you, but that's all kept with one motive in mind, that is, see, sometimes certain things which may look good to you are actually not good. That we know through our experience, and that is what it doesn't mean that we are perfect human beings, okay? But from our experience, we have learned our lesson. We don't want you to make that same mistake. That's what we are trying to do here by, warning you to not do. So sometimes we might just seem harsh to you, but see, all these are being done for you only because our ultimate motive is your well-being. You perform well. It is always a proud moment for us. So that's what we are trying to do. Grow together. Grow together. But for that, what we need is we need your cooperation. We need you to understand what we are really trying to do, because education is just not one-sided affair, okay? It's like two-sided affair. You need to cooperate, we need to cooperate, we hold our hands together, and then then who ends up being the best? Definitely you, because your future is at stake, isn't it? Your future is at stake. So that's what we are trying to do. So this channel is specifically created only for that basic reason only. Learn for free. Don't worry if you have no place to learn. This channel is made for you only, and I am trying my best to cover up as much as I can. So now, okay, leaving that aside, okay, coming back to the topic. If we remember, there was one formula, that is limiting value as x tends to a, x power n minus a power n x minus a, n into a power n minus 1. Almost similar, we just have to make some small arrangements. That is, you see, x a, but we have this x a, but we have this x plus 2, a plus 2. So maybe if we can just change these values also to x plus 2, a plus 2, then we'll have similar terms, right? So what I'll do here is x plus 2, 5 power 3 minus a plus 2, 5 power 3. What I'll do is I will add and subtract 2. Okay, I will add and subtract 2. X tends to a, x plus 2, 5 power 3 minus a plus 2, 5 power 3. So x plus 2 minus a plus 2. By just taking minus common, both becomes plus, positive values. Right. So now you see, we have here, we just assume that's x power n minus a power n, x minus a. Same terms. Just that another condition that we have to take care is that to use this formula, please don't create your own formulas. Okay. There is time. Don't be so impatient. Your time will come with to discover new formulas and all that. Let's learn the basic things first. Okay, after that you can, maybe in the long run you can do lots of things. I know you can do a lot of things. So here what happens is x tends to a. What is our value of a here for this particular question? Is a plus 2. So this also should be like x tends to a plus 2. But that's quite understandable because see, as x tends to a, then what will happen? Since we know the concept of limits, x plus 2 will also definitely tend towards 2 only, because the same quantity is being added to both the sides. So if you have 10, x equal to 10, then if you add 2 to both sides, x plus 2 will be equal to 10 plus 2, that is 12. So you're adding same quantity, so definitely they are going to shift to that same particular values only, isn't it? So as x tends to a, then x plus 2 also will tend 2 more, that is a plus 2. So this can also be written as x plus 2 also tends to a plus 2. So now what we have here is the formulas and theorem, these are just the model, just like the uniforms that students wear, but it doesn't mean that all the students look alike, they are the same with, they look same with the uniform. No, only the uniform is same, but different people, they look different, they have different hairs, different fashions, different designs, different people. So this is just a uniform which represents a school only, but people will be different. That means the values of x, a, they can be different, but as long as they are under the same, they follow the same theme, then we can use the formula. That's what it means. So you see here, x, a, a. So I think it matches, isn't it? X power n minus a power n x minus a. So then now what we can do is we can use the formula that is n into a power n minus 1. What is the value of n? 5 by 3. What is the value of a here for this question? It is a plus 2 n minus 1 power n minus 1. 5 by 3 minus 1. So that's going to be 5 by 3 a plus 2. 5 by 3 minus 1, that's going to be 5 minus 3, 2 by 3. So this will be your solution. 5 by 3 a plus 2, 2 by 3. Alright. Okay, moving on to another question. Let's do some questions related to trigonometry. I don't know which question this may be, I guess 6. Limiting value as x tends to pi by 4, sec square x minus 2, tan x minus 1. So here also if you put pi by 4, you are getting 0 by 0. So we will simplify it further. So I'll just write here, that is limiting value x tends to pi by 4. Sec square x from class 10 trigonometry, we know that it is 1 plus tan square x, isn't it? Tan x minus 1. Right, sec square x is 1 plus tan x. Okay. Sorry, this is 2. Alright, so what do we have next? That is x tends to pi by 4. We will have tan square x minus 1, because 1 minus 2 is minus 1. Tan x minus 1. Now let's continue here. That is limit x tends to pi by 4. Again, 1 I can write as 1 square. So again, see a square minus b square. We just did, no? A square minus b square. What is a here? Okay, I'll just write. So that is like tan x square minus 1 square divided by tan x minus 1. So what is the formula of a square minus b square? We've just done that in the previous problem. That is a minus b, a plus b, doesn't matter, a plus b or a minus b, into a minus b upon tan x minus 1. So same quantity, product cancels, equates. So what do we have? X tends to pi by 4 tan x plus 1. So now we know that definitely we can use the value of x equal to pi by 4, because we are not going to be getting 0 by 0, isn't it? So then we can use tan of, remove the limit pi by 4 plus 1. Now tan pi by 4 is 1, 1 plus 1, our solution is 2. Simple if you know how to do it. For that, of course, as I say, what is the trick? Practice, practice, practice and practice. Okay? Alright, maybe another question, maybe one last question. 7. Limiting value as x tends to 0, tan x minus sin x upon sin cube x. Okay, so now let's see how do we solve this. This is also going to be a good question. So here also if you put x equal to 0, I think you will be getting 0 by 0. So now let's solve this. Tan x, see all this will come to you definitely with practice, okay? Sin x by 1 upon, let it be as it is, sin cube x. So that's going to be limiting value, x tends to 0, LCM cos x. So I have sin x minus sin x cos x, taking out the LCM, right? Sin cube of x. So that's going to be limit x tends to 0. Sin x I'm taking common. So from here, 1 minus cos x. And this one, of course, I'm taking it down. Cos x taking into the denominator, sin cube x. So 1 sin x sin square. So what is left for us? Limiting value x tends to 0, 1 minus cos x upon cos x sine square x. Alright, so that's going to be limit x tends to 0, 1 minus cos x upon cos x. Now from class 10 trigonometry, sine square x, we know we can also write 1 minus trigonometric identities, 1 minus cos square x. So we have been doing these formulas over and over again, so I will not repeat that again, because 1 minus cos square x, not because of trigonometric formula but simple because of mathematics application. What do we know? Again, a square minus b square is what? Just now also we have done a plus b into a minus b, so we're going to be using that. 1 minus cos x by cos x, so you see 1 I can write 1 square, no problem. So a square minus b square, that is a plus b into a minus b. So 1 cos x, 1 cos x, 1 common factor. So what do we have? Limit of x tends to 0, 1 upon cos x, 1 plus cos x. So now I am sure that I'm not going to be getting 0 by 0. So I'll remove the value of the limit, substitute. So it's going to be 1 by cos 0, 1 plus cos 0. So 1 by cos 0 is 1, 1 plus cos 0 is 1. So 1 by 1 into 2. What is the value then? 1 by 2. 1 by 2. 2 is the value. Okay, value. Alright, okay, so this will be some of the problems that I have shared, but this is not it. Many problems are there. Okay, so maybe in some other videos again I will be giving you some more problems, which maybe when I'm able to go live, or we will be discussing upon all those problems. So for today I think this should be enough. Please practice. There will be more varieties of questions. You can check out the net also, and you will find many questions. For any person who is eager, there is always scope for learning, and materials are always available. But you cannot expect the materials just to come to you. You have to seek for it. Okay? Alright then, that's it for today. So thank you so much for being with me in the class till the end. If you have liked, please do like it, and then do subscribe, as well as share with everyone so that they can also learn. So till then, see you in the next video. Next video is going to be about derivatives, so please don't miss out that video. Okay, see you, take care.